So we'll be determining the Planck's constant using LED today. So it's a very easy experiment, a very simple experiment, because all you need is a diode set or DC power supply, a millimeter, and a voltmeter to take the voltage. That's it. So what is LED? LED is a light emitting diode which converts electrical energy to light energy, as we already have seen. So now, when it's properly biased in PN junction, then we can easily get the bulb of the LED glow. So the basic formula used here is E is equals to EV, where this V is nothing but the knee voltage of the LED. So equating this to the Planck's constant, like H nu is equals to EVK, we get it as E lambda Vk by C as the Planck's constant. Okay. So now we'll move on to the connection. So first I'll be doing this cycle fully. So from the positive of the cell, I'll be connecting it to the resistance. So from the resistance, I'll be connecting it to the positive of the milliammeter. From the negative of the milliammeter, that is, as you can see from here, I'll be connecting it to the LED. First we'll do red, positive. Now from negative of the LED, we'll be connecting it to the cell negative. This is the first connection. Second connection is also easier, where the positive of the voltmeter will be connected to the positive of the cell itself. Sorry, LED, as you can see. And the negative of this thing will be connected to the negative of the LED. So we can read the potential difference across this. So now, moving on, what we do is, so as you can see, the voltage is 0 and the current is 0. And as you can see, the voltage here is 0. So you will be taking the voltage readings only across this and the current reading across this. So the current should be in DC, as I've already kept it, as you can see. So now, in steps of 0.2, you'll be varying this. Yeah. So as you'll be reading the voltage reading here,
This you make sure it's an voltage.
yeah, and you make sure this is in voltage, so it's reading voltage. So as I've kept it at 0.2 voltage, the current is still 0, as we can see the milliammeter. So moving on with the values, you go in steps of 0.2, that is, I've kept it at 0.4 now, and it is still at 0. At a particular point, at a particular voltage, the current will shoot up. As you can see, at 1.54 voltage, I have got the current to be 1. So, but you can take it as 1.6 here. So it's isomer 1. So it's 1.6, you got 0.02 as your ammeter reading. So you can note this down. Now increase it up to 1.8. So as you can see, at 1.8, we are getting 0.53 as an ammeter reading. So keep on increasing this up to the maximum current. The maximum current which you can read in this ammeter. So basically you can read up to 20 milliamperes. So you can increase it. So 2.1 is the last reading in the voltmeter and the corresponding current. So this you will repeat it for orange, green and blue light, and the corresponding. So when you draw the graphs as shown in the figure, if you take voltage across x-axis and current across the y-axis, you will get a curve. This curve, when you extrapolate the curve to touch the x-axis, that is only the linear part. If you just extrapolate it to the x-axis, you will be getting the knee voltage value. So once you know the knee voltage value, so you can make a table like this. For color red, the wavelength will be given to you in the exam. So it's 6200 Armstrongs. So now this is the knee voltage. So lambda Vk, when you find out the lambda Vk value, it should be almost a constant. Okay, so the lambda Vk will be almost a constant. So you can take the mean of it. So when you take the mean of it, Planck's constant is a very simple calculation. H is equals to E lambda Vk mean by C.